are we? Okay, let's see if it's recording. Yeah, it's recording now. Okay, let's get started. Okay, problem number 1. Do we have anyone? Did you guys do it? What's your answer?
This is not the packet that you sent out to us.
It is the packet. Homework, the second homework, right?
Yeah, this is the second.
Yeah? So you should have Olympiads 3, 4, and 5. So this is the homework that we are going to review today. So Sophie raised the hand. Let's hear it from Sophie.
So we just find the greatest common factor. And because
Sophie, can you read the question first?
a set of marbles can be divided in equal shares among 2, 3, 4, 5, or 6 children with no marbles left over. What is the least number of marbles that the set can have? So, least common multiple.
Yeah. So Sophie, are you saying we need to find the least common multiples, right?
And
Four.
Because
multiple of
3,
2, 3, 4,
3 is a multiple of 6, and 2, no, because 3 times 2 is 6, and 2 times 2 is 4. Whatever multiples 4 are, those are multiples of 2, and so whatever multiples 6 are, that are multiples of 3, so we just have to find the least common multiple of 4, 5, and 6.
Okay. So this reduced to the least common multiple of 4, 5, and 6. Okay, everybody agree? So what Sophie said was number 1, she said 6 can be factorized by 2 times 3, and 4 can be factorized by 2 times 2. And then if a number is the multiple of another number, such as 6 is the multiple of 2 and 3, then the least common multiple between 6 and 2 or 6 and 3 is just 6, right? So then this whole thing reduced to what? We're just looking for the least common multiple of 4, 5, and 6. So how do we solve a question like this? So there's generally 2 steps, okay? So step 1 is called prime factorization. So we don't have to really understand this frame. All we need to know is that we need to, so let me just write it in the plain language. We need to write the numbers as expressions of products of prime numbers. Okay, so that's all we need to do for the first step. So let's take a look at 4, 5, and 6. How do we express 4 as a prime number? 4 is 2 times 2, and 5 itself is a prime number, so 5 is 5. Or you can say 5 is, 5 to the 1. This is the power exponent. Okay, so for those of you who do not know power or exponent, we can just write 5 as 5, 2 as 4 as 2 times 2, and then 6 as 2 times 3. So let's check again. All of these are prime numbers. So we have done the first step of writing the numbers as expression of products of prime numbers only. Okay, prime numbers only. Now second step for us to find the least common multiple is then we need to how do I say this? Multiply. Yeah, we need to multiply all prime numbers. All prime numbers that we just found, and including all prime numbers of the greatest time they have appeared. The greatest time they each have appeared. So what do I mean by this? We need to multiply not just 2 times 5 times 3, but 2 has appeared twice in 4. So we need to multiply 2 times 2 times 5, right, times 3. Not just once, but twice, okay? The greatest time it has appeared in any of these numbers. So we get 60 here, okay? So any questions? Let's check if 60 is really divisible by all of them. And also, is that the least number of marbles that the set can have? Okay, so number one, okay, step number one, we check if 60 is divisible by all of these 5 numbers. That is definitely true, right? And then step 2, we're looking at, okay, so can a number that's smaller than 60 work? Let's try 30. Does 30 work? No, 30 does not work for 4, right? Let's try another number. Let's try a number that's divisible by 60. Maybe it's 20. Does 20 work? 20 does not work. Okay, so that's how we made sure that 60 is the least number of marbles that the set could have. Okay, hold on for a sec. I think my phone is ringing. Okay, anyways, that's taken care of. Any questions on the first question before we move on? Everybody got 60 by a show of hand. Let me see, how many of you got 60? That's good. Yeah, that's very, very good. Okay, so by the way, if you have noticed, for every one of these problems, we have a time. We have, for example, this one, we have 4 minutes, then we have a percentage down there. So the 4 minutes basically means that's how much time it's allocated to you for this problem, okay, for this particular problem. And then that 44% means out of 100 students who completed this problem, only 44 of them got the right answer, okay? So now when you look at a problem, let's move on to the second one. So obviously only 7 students out of 100 students within 5 minutes got this question right. But for those of you who have taken our summer class, you will know that this is a very typical average speed, right? This is a problem type. So type of problem, this is a average speed problem. So if you know the formula that we're supposed to divide the total distance by total time, okay? So if you know the formula here, you should be able to figure this one out. So let's find someone to, Kevin, you wanna try? Why don't you read the problem first?
So, a motorist made a 60-mile trip averaging 20 miles per hour. On the return trip, he averaged 30 miles per hour. What was the motorist's average speed for the entire trip? So first I drew a line representing the range equals 60 miles. So that would be the trip, and so that would be like
one way.
Yeah, and then I drew an arrow representing 20 miles per hour. So I wrote that time equals length divided by speed. So yeah. for this way, 60 divided by 20 equals 3. So that'll be 3 hours because it said it averaged 20 miles per hour. So like the way
back.
yes. So the way back, I did so the way back it equals to 2 hours because 60 divided by 30 equals
30. Yeah.
So the average speed basically equals 60 plus 60, which equals the entire distance of the trip.
Okay.
2 plus 3 hours.
Yeah, so the total time is 3 plus 2, 5 hours. The total distance is 60 plus 60 or 60 times 2, which is 120 miles. Then the average speed, we just put the formula up there. The average speed is the total distance divided by the total time. So we should have 24 miles per hour, okay? We should have 24 miles per hour. And a very easy mistake to make is to just sum up these two speed and then divide it by 2. So this is something that a lot of students would make a mistake, okay? And this is not the way to do it. Let me go back and circle the answer here. For the first problem, we have 60. I want to circle it because sometimes I write too much and then it can be messy. People don't know. Okay, so I want to make sure I put the units there too. 24 miles per hour. Very good. Now, question number 3. Anyone? Did you guys do it? Question number 3. Yeah? Let's see. Hannah?
Yeah.
Hannah, why don't you read the question first?
The 4-digit numeral 3AA1 is divisible 9. What digit does A represent? Okay, so what I did all the numbers from 1 to 10, but I don't know if there's a quicker way.
Yeah?
I
Oh, so
did
you
this.
tried, yeah?
Yeah, and I did
So,
this and I got it under 4 minutes because I don't use the way that everyone else has used. So I put random numbers. Pretend I did 3331.
yeah. So what if I tell you the divisibility rule of 9 is that what? If the sum of all digits is divisible by 9, then the number is divisible by 9. What if I tell you that? Anybody who did in a different way? Melinda?
I did it in the way you're saying it right
Yeah?
now. Like,
So what did you do?
first I tried 9 minus parentheses 3 plus 1, and that equaled 5. So it didn't work because I had it divided by 2. But I also know that it can also be a number that is also divisible by 9. So,
Okay. So this way you got what? A plus A equals 5. And you know it does not work because 5 is not divisible by 2. And you need to have a whole number. A has to be a whole number.
yeah.
Okay, so so 9 does not work. Then what did you try?
I tried 18 because 9 plus 9 equals 18.
Very good.
That gave me 14, and 14 can be divided by 2, and that equals 7.
Okay.
Then
And
I
then, yeah?
4 if it was right, and it was.
It was. Okay, you checked. What if we go to 27? Melinda, what does that happen?
Can't work because it's the number that I got was too big to be divided by 2, and
Yeah?
from 0 to 9.
Okay, so then 27 minus, okay, so this is not only that A would not be a whole number. A has to be a whole number between 0 and 9, okay? So A has to be somewhere there. Actually, I'm going to use a bracket because it's inclusive. Inclusive means A can actually be 0 or 9. Okay, so A has to be a whole number between this bracket, okay? So that's why we can only choose 18, okay? So let me frame this. A is 7. And Melinda said she tried to use 3771 divided by 9. Let's try this. If it works, okay, then 1, we got 81 left. Yes, so it's divisible by 9. Very good. Very good. So that's basically the thinking of this. The only trick here is to know the divisibility rule of 9. Oh, actually, I'm going to give you guys some extra homework, okay? So this is a task, extra task here. I want you guys to find out the divisibility rules for, okay, this is a big task. But for those of you who have already, you know, many students in my Mondays class, they already know this. So I need you guys to find out the divisibility rules for all of these numbers, okay? And it's very important. It might not be important for, you know, students that are not entering these contests, but for you guys, it's very, very important that you know, because, you know, we can change this to by 4, something like that, okay? We can change this 9 to any of these numbers here, and you should be able to use the same or similar rules to figure it out. So that's your, let me put a circle here, right? So something for you to extra fun for you to have. Divisibility rules for 2, 3, 4, 5, 6, 7, 8, 9. Okay, so then we're moving on to the next question. This one is a little tricky. Okay, so for the third graders here, if you are not sure about decimals, fractions, it's okay. Because let me tell you, if we are moving on to the whole set of problems, you will see that there's only like maybe 1 or 2 problems that involve fractions or decimals in the whole set of contests. So your goal is really to get all the easy questions, okay? Everything that you can do absolutely right. Then leave out those that are extra hard. And let me give you a perspective here. Last year, I think the whole of BMIS, the best student only got 23 questions out of 25. So it's very rare for someone to have 25 out of 25. Okay, so if you miss 1 or 2 of the really hard questions, don't feel bad at all. So our goal is to get the easy ones correct, okay? And if you can do that, you're already one of the top. So number 4, it's a little tricky, but let me see any of you, if any of you has cracked this problem. Let me see. Jacob, go ahead. Jacob. Jacob, I think you're on mute. Are you? Can you guys hear Jacob? No?
No.
Jacob,
No,
we cannot hear you.
no.
Is your
I
speaker
think it's
plugged
his
in?
headphones. I think it's
Is
his
your headphone plugged in? Sometimes, you know, you're wearing headphone, but you're actually. Now, Jacob, can you say something? Yeah, we still can't hear.
Jacob, try
Yeah, so
unplugging your headphones.
anyone else? Let's see. We can't hear Jacob. Okay, Sophie, go ahead.
Express the following sum as a simple fraction in lowest terms. So 1 over 1 times 2 is the same as 1 over 1 minus 1 over 2, because 1 over 1 minus 1 over 2 is
It's just 1/2, right? It's just right. Thank you, Sophie. So that's exactly the trick here. So we can do the same for all of them, okay? So that's the basic trick here. If you know this trick, then it becomes very easy for you because this original problem becomes, we can write this thing out to, remember to put parentheses, okay? Because this parenthesis, the thing inside of the parentheses represent the fraction here. So we can just keep writing. Let me shift this to, okay, I'm going to frame this up so that we don't cross the borders here. And then it becomes 1/4 minus 1/5, 1/5 minus 1/6. So when you get rid of the parentheses, again, guys, if the sign before the parentheses is a plus sign, you don't do anything. You pretend the parentheses don't exist. You just keep writing down and getting rid of the parentheses. So the whole thing becomes,
And
right? So these things all cancel out, all of the things in the middle. The whole thing becomes 1 minus 1/6. So that becomes a very easy fraction. But I have got, you know, people, I've got quite a few people from my Mondays class. So they insist that it's not that hard if they just go ahead and do the whole thing, which I completely agree. So let's do the hard way out. So let's say let's just say this whole thing becomes 1/2 plus 1/6 plus 1/12, 1/20, 1/30. And they find the least common multiple of all the denominators is 60. So then they say, okay, 1/2 is 30/60, and 1/6 is 10/60, so on and so forth. So they keep doing that. That works too. And finally, they added everything up. 30 plus 10 plus 5 plus 3 plus 2. So they have 50/60, and that's just the same as 5/6. So either way, you can use my first method or you can use my second method. The problem with the second method is that this thing can go on and on. Sometimes what if they say, okay, this is 6 times 7 and this is 7 times 8. And if such things happen, then you really can't resort to something like this, right? You have to really know the trick to get it right. So, but for this particular question, you can use either method. Okay, guys? So the answer is, let me circle this, frame this. The answer is 5/6. Either way, we should get 5/6. Okay. Now, the last question on the first page. Okay, Aaron, you want to talk about this one? Charlie?
no, I don't want to.
Charlie, no? Sam, you wanna try this one? No? No one? Okay, guys, let me talk about it. If we count by 3, starting with 1, the following sequence is obtained. 1, 4, 7, 10, so on and so forth. What is the 100th number in this sequence? Okay, so we're counting by 3, starting with 1. 1, 4, 7, 10, so on and so forth. And then we need to find out what is the 100th number. Okay, what is this number? So first of all, we find how many of these intervals, spaces, how many of these spaces? Because we know the space, the size of the space is 3. So we're asking how many intervals do we have? Or spaces, whatever you call it. Do we have here? We have 100 minus 1 equals 99 intervals, each of the size of 3. Okay, so that's what we have. And so what we're going to figure out is 99 times 3 equals, what's this? 99 times 3. Let's see. 297. Okay, so from here all the way to the hundredth number, there is 297. But we do have to add that 1 because we're starting with 1. Then we got 298. So your 100th number should be 298. Okay, it's not that hard. So once you kind of illustrate, you get the sequence out and you're looking at the intervals, the space, and it's very easy for you to find, okay, I just need to count how many intervals there are. There are 99, and then what is the whole thing worth? This whole thing worth 297. Add back that 1, then this 100th number should be 298. Okay, so that's question number 5 on the first page. Now we're moving on to the second page. Let's see. Yeah, so this is your Olympiad 4. And this first question, there's no trick. It's basically a calculation for fractions and decimal. So let's see. Charlie, did you guys do it?
I did it.
Okay, let me see what you did. Why don't you read the question first?
Okay.
This is your, Olympian 4.
I found it. 100 pounds of chocolate is packaged into boxes containing 1 1/4 pounds of chocolate. Each box is then sold for $1.75. What is the total selling price for all the boxes of chocolates?
Okay, so what do we do here? We
So
first
for me,
find out how many boxes there are, right?
Yes, so I did 1.25 divided by 100.
So 100 divided by 1
1/4.
Yes, and
Then I
then
got-
how did you figure this out? So 1 1/4 is just 5/4, right?
Yeah.
And so we flip the sign, change the sign, and flip the denominator and the numerator.
Yeah.
Then we cancel out, simplify first before you multiply. And then this is just 80 boxes becomes, right? Then what's your step 2?
Then my step 2 is I multiply the number of boxes and how much each box costs.
Very good.
Which got me $140.
Very, very nice. Thank you so much. So let me put it out here. We're doing 40, and then this is a 60, 1, 4. And then because we have 2 decimal points, let's move the decimal point from here twice over. So we have $140. So there's no trick, okay? If you know how to work with fraction and decimal, you should be able to get this question. That's it. Now, this next question, I want to talk about it. This question is not that hard, but it's one of those things that it's kind of hard to explain, right? So the question said, in the multiplication problem at the right, A and B stand for different digits. Find A and B, okay? So we can see from this long division, I'm sorry, not long division, but from this long formula here, okay? So AB times AB times A equals 114, okay? And then AB times B times B equals 304. And you can start with either, but I want to pick the number that's smaller to start with. So I want to stick with the first equation here. And then my goal is to figure out, can I factorize 114 into something that's a single digit and a double digit number, okay? And there's also a relation between these two numbers. The relation is that the single digit number is also at the tens place of this double digit number, okay? So let's see, 114. First of all, we know it's an even number, so it can be factorized by 2 times 57. Does that work? 2 does not appear at the tens place. So this is definitely not right. Then I'm trying, okay, all of the digits add up to 6, okay? So it's divisible by 3. So I am going to factorize this by 3 times, okay, 114 divided by 3, that's 24, 38. Okay, so 3 times is 38. That's a possibility. And let's check. Oh, very nice. So this could be A. This could be A and B. Okay? And guys, that's it. Another possibility is 114 could be divisible by 6. Okay? So if we're going to factorize by 6 and another, so 6 and 19. But again, 6 does not appear at the tens place. So this one is also out. So that's it. Just if you have tried 3 and 38 first, then you got it. You know, you can finish this in 30 seconds. So let's try it. 38 times 83. 144 and 304. So very good. That's it, guys. It's just one little trick here. Let me write A equals 3, B equals 8. So again, I want to review what we did. We observed this long formula, and then we said, okay, AB times A is equals 114, AB times B equals 304, okay? And then we want to work with a smaller number rather than a bigger number. So we're saying, okay, I want to factorize 114 into 2 numbers, one single digit, one double digit, and the single digit number should also appear at the tens place of the double digit number. So the only choice for us here is 3 times 38. So A is 3, B is 8, okay? So this is one of those questions, if you understand what the question was asking, and then there is really not much trick, right? But it's kind of hard to explain. Oh, this kind of a geometry problem. Anyone? Yeah, we want to find someone to, how many segments? How many segments? Largest number of segments. Okay, so no one wants to talk about this. This one is a little bit tricky. Okay, let me give you the basic thinking here. Charlie, you want to talk about it?
Yeah.
Yeah, go ahead.
Wait, is it in the rectangle at the right one?
Yeah, the third question here. Yeah.
All right. The line segment M and N separates the
Yeah.
rectangle into 2 sections. What is the largest number of sections into which the rectangle can be separated when 4 line segments are drawn through the rectangle?
Uh-huh.
So what I got was
Did you count how many?
Yeah, I got 11.
Very good. Yes, I got 11 too. So apparently that's the correct answer. But what's the trick here, Charlie? When you add your first line, did you just draw any line like this? Did you do that?
When I started adding my first lines, yes. But once I started going to the third line,
Yeah.
I crossed through 2 lines.
Okay. So yeah, he said something that's very, very important. Cross, right? So let me write the trick here. What color was I using? Was I using blue? Okay, blue. Okay, I want to stick to the same color of pen every time. Anyways, so Charlie said cross. Okay, so the trick here is to intersect. Okay, every time when you adding a new line, every time you add a new line, you want to make sure the new line, the newly added line, intersects with all existing lines. Okay? So let's see, if we're adding just one line, if we're just adding one line, and then if I do this, I'm getting 1, 2, and 3 segments, okay? This is when I'm adding just one line. However, if I make sure that I intersect with the existing line, which is this MN line here, okay, so if I make sure, oh, it's still eraser, I didn't change it back. Okay, so if I made sure that I intersect with this line here, then I've got 1, 2, 3, 4 segments. Okay, that makes a huge difference, right? It was 3, now I added one more. And we want to continue with that kind of thinking when we add more lines. So let me show you what we did here. I want to add the numbers after we have finished everything. Otherwise, it'll be too busy. Okay, so the first line here, I did that. Okay, so 4 segments. Now this third line, what I did was that I was intersecting with the 2, all of the 2. Okay, so this is my third line. Now my fourth line, I made sure that I intersect with all, let me see if I can do it, with all 3 lines here. Yeah, so then now let's count. Why is Andy always dropping out and then coming in? I don't think his internet is very stable. Let's try to count, do it in clockwise. Okay, clockwise way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the largest number of segments is 11. 11 segments. Okay, again, the key, intersects. Okay, intersects. When every time you cross 2 lines, you're making actually one more, right? And then if you can do that with every line, you're going to get the maximum number of segments. So that's the thinking. Now moving on to the 4th problem. Oh, this is another trick with fractions. Okay, but actually you can just do like, you can just try it if it works, because my Mondays students, they didn't know the trick. They just tried it. Okay, so what they did, let me show you what they did. They said 1 over 3 equals 1 over a plus 1 over b, where a and b are different whole numbers. They're whole numbers. Find the value of a and the value of b, and they have to be different, right? So my class on Monday, they said, okay, I first tried, what if a is 1? So they did, okay, what if a is 1? 1 over 3 equals 1 plus something. They're like, no way, this is not right, because this is already bigger than 1/3. So they said a cannot be 1. And then they said, what if a is 2, right? What if a is 2? And now they're having the same problem, right? So 1 over 2 is already bigger than 1. I'm sorry. Oh yes, 1 over 2 is already bigger than 1 over 3. So, and then you're saying there's another thing that you need to add to. So that didn't make any sense. A couldn't be 2. Then they keep trying. They said, what about a is 3? But that still doesn't make any sense, because you're saying 1 over 3 equals 1 over 3 plus something, right? So a cannot be 3 either. Now they say, what if a is 1 over, what if a is 4? So does that make sense? Now finally it kind of makes sense. So then they're like, what about b? What could b be here? So 1 over 3 minus 1 over 4. So they figured out if a is 4, then b is 12, okay? So that's basically, now I'm going to give you guys a little bit, 15 seconds to look at this problem. And when we come back, I want to ask any of you did you see any pattern, right? Did you see any rule? If I change the number from 1/3 to 1/4, what should we do here? Okay, so if we change the number from 1/3 to 1/4, what should we do here? Okay, guys. Okay, so I want to repeat my question here. Okay, my question is, now I want to change 1/3 to 1/4. Okay, so now what do we do here? Sophie?
It has to be at least 1/5 or lower.
Very good. So we don't have to try 0. Oh, I'm sorry. We don't have to try from 1 to 3, those numbers, right? Or even 4. So we're just going to do A equals 5, right? So what is B here, Sophie? Yeah? B is 1/20, okay? So guys, in fact, this is I don't want to talk about, I don't want to talk too much into this, but you should be able to figure out if I change, because this could appear in this contest. Very well, it can appear. Okay, if I change this 3 to any number, you should be able to figure this one out, okay? By using the same thinking that we did here, right? Same thinking. And these are things for you to, if you have time, some extra fun for you, okay? So if I change 3 to 5, 6, 7, you should be able to figure out as well, okay? So now what about the next question? Next question is kind of fun. It's very easy, but you need to understand. You need to understand what the question was asking. Anyone? Anyone? Aaron, did you do it? Andy, Kevin? Kevin, are you raising half of a hand? Yeah? Kevin, go ahead.
I'm not sure if this is correct.
Yeah, but tell me, just read the question first, why don't you?
So it says P and Q represent numbers.
Okay.
How do you say P?
You can say P star. You can say this is a
P
star.
Q means P plus Q over 2.
Yeah.
What's the value of 3 star parentheses 6 star 8?
Okay. So what about it?
So
What did you do? Step 1.
Step 1, I looked at 3. So if 6 star 8 equals
Okay.
Q, it equals to Q, and then 3 equals to P. Then I did like 3 star parentheses 6 star 8.
Uh-huh.
I did 3
6 star 8 becomes what? Becomes 6 plus 8
over
divided
2.
by 2.
And
That's 7.
And then I did
Then it
3
becomes
plus 7
3
over 2.
star 7. Yeah, very good. Then it becomes that.
Yeah.
And it's 10 over 2. So the answer is 5, right?
Yeah, that's what I got.
Very good. Yeah, Kevin, you did exactly right. So it basically is saying, it gave you, it's like we're defining this thing with this formula. So P and Q, you basically just P is 6, Q is 8. And after you figure out the quantity inside of the parentheses, then P becomes 3 and Q become whatever that comes out from this parenthesis. And you start the process all over again until you get to the final answer, okay? So as long as you understand what the question was asking, then it becomes very easy calculations. Wow, I'm surprised only 13% of the students got this right, right? So the key here is about understanding the question. Now, next one. Next one, anyone? Did you guys do it? Andy, I saw you raising your hand. Did you do this question? Andy.
Actually, I was talking about the other one,
Okay.
but I just thought it was 3 times 6 times 8.
Oh, you thought it's a multiplication. Okay. No, it's a
Yeah.
star. Yeah, it's, yes. So yeah, okay. So that makes sense. So that's why a lot of students, maybe they thought it's that. Okay, it's not, right? It's a star. It's not the multiplication sign. Okay, so now this question, let me talk about it, okay? The numbers 2, 4, 6, 8 are a set of 4 consecutive even numbers. So they're giving you an example of what is a consecutive even number. Now, suppose the sum of 5, this is a 4. Now we're dealing with 5. One more. Consecutive even number is 320. What is the smallest of the 5 numbers? So there is one way that my Monday's class, one of them, they did it in a way, let me tell you about this method. I thought it's brilliant. So this student, she said, okay, let me just draw a circle here, and I pretend that this is the middle number. This is the number in the middle. And then she said, because they're all even numbers, so the number right after it should be +2, okay? Should be 2 more than this middle number. And she said, then I drew but what about the number that's even behind this number? Then it's 2 + 2, right? So you're just keep adding 2 to these numbers. But now I look back, what is the number before this middle number? That should be this number -2. Then so on and so forth. This first number, the very front number in the sequence should be circle -2 -2. And she said, now the question said the sum of all of them is 320. So she added all of them together. She said, okay, I want to add, she put parentheses. She said, I want to add all of them together. That's what she did. Okay, so then she observed that this, if we get rid of the parentheses, again, the sign before the parentheses is plus sign. So we're just keep writing everything. Again, this is a circle. Let me write. This is a circle. It's not 0, okay? So she said, oh, let's actually change this to a cross. Okay, to a, let's just do a weird sign here. We're putting a cross inside of the circle so that we're not mistaking this with 0. Okay, so basically we're saying we can just get rid of the parentheses without changing the signs. Now they observe that when we do that, then these 2, -2, +2, -2, +2, they all got canceled out. And then there's only 5 of these left, okay? 5 of these left. So this whole thing is 320. So one of this is, the middle number is 64. And then he went back, he said, okay, if this is 64, this must be 62, and the smallest number must be 60. So they got 60, okay? So this is one way of, and then the way that I came up with was that, you know, for any of consecutive, okay, so if it's a consecutive number and it's even number, oh, I'm sorry, and it's a odd number, 5, then the middle number should just be the average, okay? So that's my quick way. Average, the middle number is the average. So what I'm saying is 320 divided by 5, that's the average. So all of us, you know, just 10 seconds, I figured it out. The middle number should be 64 by just doing the average, okay? And then I went back the same way. 64, 62, 60. So if you know that the middle number would be the average, that would be something very quick for you to figure out. Okay, so but you can do method one, no problem at all. It's actually a brilliant method. So okay, again, this is 60 is the answer. 60 is the answer for this question. Now question number two. Question number two is so easy. And then you look at the percentage, okay? It's 6%, right? This should be, if you know, actually, this is not even a fraction, right? When we, okay, so I want to read the question first. Amy can mow 600 square yards of grass in 1.5 hours. At this rate, how many minutes would it take her to mow 60 square feet? The only thing here is a unit conversion. Okay, Andy, do you know how to do it?
Yes. So
Okay, go ahead.
actually, 3 feet is 1 yard. So technically, you just cut the time it takes to mow the yard, well, the grass by 1/3. And since it's 1.5, that means there are 3 halves, which would be, well,
Okay,
30
Andy,
minutes is
first
how long?
you said okay, let's see here, Andy. So if we say if this is a square yard, okay, 1 yard here, 1 yard here. And you said what? You said 1 yard is 3 feet, okay? So this is 1 foot,
And then if
another foot, another foot. So when we do that, what about a square yard? How many square feet are there in a square yard? We have to do 3 times 3, right?
9 squares.
Very good. That's the only trick here. So when we know that the conversion factor is 9, then what do we do? What do we do here? What do we do here? It's the same number, guys. It's basically,
do 9 divided by 100.
yeah, so basically we have this yard, this many yard, 600 square yards. And we know that this equals to 9 square, each one of them equals to 9 square feet. So 600 square yards. Yeah. Now you're taking 1.5 hours, okay? Which is how many minutes, guys? 90 minutes, right? That shouldn't be too hard. 1 hour is 60 minutes, half an hour, 30 minutes. The whole thing is 90 minutes, right? So the whole thing you take 90 minutes to mow. Now I'm saying we need to figure out 600 squared feet. And we know that 1 square yard is 9, right? And 600 square yard is also, there are nine 600 square feet in 600 square yards. Okay, so there are 9. 1, 2, 3, 4, 5,
and then
6, 7, 8, 9. Then we do what? 90 divided by 9 equals 10 minutes. That's it.
9 equals 10
minutes.
Yeah.
Very good. That's it. There's no, we don't even deal with the whole, we just need to figure out how many of these 600 square feet is there in that 600 square yards, because there is 9 square feet in 1 square yard. So there are 9 600 square feet in 600 square yards. And then the time it took for us to mow the big area is 90 minutes. Now, for us to mow just 1/9 of that area is 90 divided by 9 equals 10 minutes. That's it. Okay, so that's your second problem. Now, what about this one? This one is a little bit hard. So let me do this one. Okay, express the extended fraction at the right as the simple fraction in lowest terms. Okay, so when we deal with such a problem, the key is to take a deep breath and then copy down everything, okay? Copy down everything. When you are doing this problem, every step, do not lose any layer. I want you to just concentrate, compare, you know, this to the original problem and working from the bottom up, okay? So let's work at the first layer, 2 plus 1 over 2. And that's, the whole thing is just becoming, the whole thing becoming 5 over 2, okay? 5 over 2. Now, the second step, don't just, no, there's no need to hurry. You got 6 minutes here. So then the second step is we're only just going to flip it. That's it, okay? That's our second step. Then we come here and we copy down everything again. And the bottom becomes what? This whole thing becomes 2. And so this becomes 5 times 2 plus 2 equals 12 over 5. And so I'm not going to do anything rather than just write down 12 over 5 for this step. And I am done with the step. Then I'm going to do the second step, not second, the next step, which is to just flip it. Okay, flip this. That's it. Then I'm moving on to the next step, which is I'm going to convert this mixed number into a fraction, improper fraction. So the way is 2 times 12 plus 5. Okay, so there is 29 divided by, and that's it. I'm going to write down that and moving on to the next. The next step, we have gotten rid of all of the whole numbers. Now we're just flipping. Okay, so that's it. 12 over 29. No trick. You just need to be really slow and careful. Okay, really slow and careful. Now we have question number 4. Question number 4. This one is kind of tricky too. Anyone? Sam? Sam, you want to try? What about Ivy? And Molly? You girls have been really quiet today. What happened? Anyone? Anyone? Question number 4. Okay, Sophie? Sophie, why don't you read the question first?
There are many numbers that divide 109 with a remainder of 4. List all the 2-digit numbers that have that property.
Okay.
So it has a remainder of 4, so that means when you you have to subtract 4 to
oh, hold on a sec. Did I write it wrong? Okay. I need to write, instead of 190, it's 109. Very good. Okay, I caught that mistake. I don't want to have that kind of mistake in the notes. Okay, so let's do it. Now, Sophie, go ahead. Said we need to subtract 4 from 9. Now we have 105. Then what do we do?
And then we find all of it that's divisible by, but because it's an odd number, we don't need to check the even numbers.
Yeah, so we don't have to deal with 2, right? What do we do here?
We can deal with 3, 5, and 7, but we don't have to deal with 9 because 1 plus 5 does not equal something that is divisible by 9.
Right. So okay, so you said 3. Now 105 equals 3 times 35, right?
Mm-hmm.
What about the next one? Equals also 5 times 21, right? And did also any other numbers, guys?
7 times
15, okay? And any other 2-digit number? Any other? No, right? So let's write it from smallest to largest. Okay, so there are 3 2-digit numbers that can satisfy the equation here. Let's just try one. Okay, 109 divided by, if we try 15, okay, it equals 7, right? 109 divided by 15, 7, with remainder of 4, with remainder of 4. And we can also try 21 and 35, and it should satisfy this equation. Very good. Thank you, Sophie. Now we're moving on to the last question. And this question is really, really tricky. Did any of you do this? Any of you? Sophie did it. Okay. Jacob did it. Ivy, why don't you tell us what you did?
The dealer packages marbles in 2 different box sizes. One size holds 5 marbles and the other size holds 12 marbles. If the dealer packaged 99 marbles and used more than 10 boxes, how many boxes of each size did he use?
Yeah, so we have 2 kinds of boxes. So one is with only 5 marbles, the other with 12. 2 types of boxes. So Ivy, what's your trick? So what I did was that I found out multiples of 12 first, because I know that there has to be, you know, some numbers of the 12 marbles and some numbers of the 5 marble boxes, right? So, and then all of them together, it has to be more than 10 boxes. So that's all we know. So I'm trying the multiples of 12. Multiples of 12, it goes like this: 12, 24, 36, 48, 60. What's the next? 72. What's the next, guys? What's the next? 84 and 96. Because we know that there are only 99, and we can stop here. Okay, we can stop here because the next one would have exceeded that 99. And now what we do is that we can then subtract that 99. Okay, let's do this. Subtract, big subtract here. We're subtracting that 99 with each of this number. Okay, so from here we get 87, and here we get 75. What about this? 63, 150, 139. What's this? 7, 27, 5, 15. What about this? 3, okay? And then out of all of this difference, what are those numbers that can be divided by 5, guys?
75.
75 and
15.
15. Very good. So then, okay, so step 1, not step 1. Okay, this is step 1 actually. This is the step 1. Step 2. Let's try this. Let's try the combination. 99 minus 24 equals 75. So we got 2 boxes, okay? Not here, okay. 2 boxes of 12 marbles. And then we got how many? 15 boxes of 5 marbles. And 2 plus 15 is 17, bigger than 10 boxes. That kind of satisfies, right? But let's try the 15. Okay, let's also rule out just to make sure. Step 3, we want to do 99 minus 84 equals 15. So this would give us 7 boxes of 12. And that would give us 3 boxes of 5. However, 7 plus 3 equals 10 boxes. And it does not satisfy the condition that the total number of boxes is greater than 10. So we have to go back to 2 and 15, okay? We have to go back to that. How many boxes of each size did she use? So then we can say he did 2 boxes of 12 marbles and how many? And 15 boxes of 5 marbles. Yay. Okay, I'm going to post the recording and the notes to Google Classroom. Any questions before I let you guys go? It's so much fun, right? So math is like one of those things that once you know the trick, you're like, aha, you have that aha moment. And you're like, oh, I really got smarter today, right? So I hope you all got smarter today, okay? So if you have no questions, I'm gonna let you guys go. And again, we're going to post everything. Do your homework, try your best before our next class, okay? Have a nice weekend, guys. Bye-bye. Bye.
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 Bye.